Right, you're looking at the three-phase motor, induction motor. Remember, there's two types of motors. You get a squirrel cage motor and you get a wound motor. Notice that induction motors have no brushes, and so it has a low starting torque as well. That's one of the characteristics of induction motor. The benefit and advantage of it, that it doesn't explode. It can't lead to explosions, because let's say there's combustible gases in a certain area. This motor, because it doesn't have brushes, there's no sparking, and therefore it can be used safely in industry. Right, so state the reasons for the skewed rotor. So remember, with the squirrel cage motor, the rotor is on an angle. So the reason it's on an angle is to prevent cogging. So cogging means you don't want the motor to lock up. And it also leads to quiet operation. It reduces the magnetic hum. And it increases the slip for a given torque. So now we need to understand what is slip. And this is where our calculations lead to. So what is slip? Slip is the difference between the rotor speed and the rotating magnetic field of the rotor. So there must be a difference between the speed of the rotating part and the speed of the rotating magnetic field. So don't forget that the magnetic field is rotating on the outside. This is formed by the stationary part of the motor, and inside, this is like your armature, the rotor speed. So there must be a difference between the rotor speed and the speed of the rotating magnetic field. So how do we know these two differences? So we call that one the synchronous speed. That's the rotating magnetic field, is the synchronous speed, and then we got the rotor speed. So we got a thing called slip. So slip will be ns minus nr, and that will give us our slip. But if you want to calculate percentage slip, then percentage slip is this formula here. So percentage slip will be ns minus nr over ns times 100%. There are formula sheets. Please check the formula sheet to see if this is there. And then slip is equal to the percentage of ns. So if you want to calculate the slip and they give you a percentage, so you just have to say percentage of ns, and that's how you'll calculate the slip. Right, so those are our main calculations when it comes to the motors. And also outputs and inputs, efficiency, those calculations as well. Right, we're looking at the calculations of slip. So the topic here is three-phase motors and starters. You can write down the question and pause the video, and then we can start. So the first thing we're going to look at is the slip of the motor and then the percentage slip. So you need to know two formulas. Right, so notice we're looking at slip, and slip is the synchronous speed minus the rotor speed. All you have to do is substitute the values and subtract. We will get 150 RPM. Next, we're looking at the percentage slip. We need to get the formula, synchronous speed minus rotor speed over synchronous speed times 100%. Substitute your values into there and get your answer. And the next question says, a star-connected three-phase motor with a 4-pole pairs per phase draws a line current of 6 amps when connected to a 380 volts 50 hertz supply. The power factor, that is cos theta, is equal to 0.85, and the efficiency is 90%. So pause the video and write down the question. The first question says, calculate the synchronous speed. Right, I'm sure this formula comes to mind. So the synchronous speed is equal to F times 60 over P. Don't forget that P is the pole pairs. Right, so we'll substitute the pole pairs as being 4 as given. And notice the frequency, I circled it as 50 Hertz. Substitute and get your answer. Right, so we got the answer. The next one, we want to calculate the percentage slip if the rotor speed is 700 revs per minute. That is very basically like the same one we just did. Right, start with the formula, substitute into the formula. Don't forget that ns is the synchronous speed calculated above. 700 is the rotor speed. Right, answer. Right, next I wanted to calculate the output power. Notice that the efficiency was given as 90%. Right, so that's our formula to calculate the power. And then notice that is just apparent power. So how will we calculate true power? That will be our true power times cos theta, and then now to get the efficiency to get the total final power, notice that efficiency will have to come in, so times the efficiency. Right, do remember this formula. We will substitute V is equal to 380 into the formula, times the current, which is 6 amps, times cos theta, which is 0.85, times the efficiency, which is 0.9. Notice that the efficiency was 90%. 90 divided by 100 will give us 0.9. Right, and that will be our answer in watts. To convert it to kilowatts, divide by 1000, and that will be kilowatts. Right, and that's our questions on calculations. Let's look at another one. Right, with the motors, it also comes with application questions. And notice they give you a nameplate, and on the nameplate you must notice the frequency. If the frequency is 50 Hertz, one of the questions I could ask, is the motor suitable for South Africa? You will say yes, it is suitable, not because of its power or whatever else, but because of the frequency. Because remember that South Africa, we use 50 Hertz frequency, so this motor will be able to work in South Africa. So note the 50 Hertz. Also, how we know our 3-phase in South Africa, our 3-phase is 380 volts. That is our 3-phase value in South Africa. Right, let's continue with the questions. Don't forget to write down the questions and then we can continue. Pause the video. Right, first question, is the motor suitable for SA? Our answer is yes, because of 50 Hertz, 380 volts. South Africa uses 50 Hertz. Our next question said calculate the input power to the motor. So input power, don't forget the formula, and this will be true power. Best to write the formula out with multiplication in between. With all the stress, you don't want to make a mistake. Substitute into the formula. The voltage is 380 from the nameplate. Notice that the current was 24 amps and the power factor is 0.8. Notice it can also read as PF and not really as cos theta. So on the nameplate, sometimes we'll have PF meaning power factor. Cos theta also means power factor. Remember to double punch in the questions, double punch in the numbers just to make sure that your answer is right. Don't get these questions wrong. That's our answer in watts. Don't forget to convert it to kilowatts, count the places, or you can divide by 1000. Remember that the symbol P with cos theta will be true power, P. Next, we're going to calculate efficiency. We're going to write out the formula. Efficiency is output over input. Now, to get the output power, we need to look at the nameplate. Notice that it said kilowatts and it said 10. That will be 10,000. Right, so 10 kilowatts is 10,000. Substitute and finish off. Right, and the efficiency is equal to. Right, the next question there, we need to find the synchronous speed. If the slip is 4%. Try that one out quickly, pause the video. Right, in this question you have to make NS subject to the formula. This is a mathematical question. Please try it out, pause the video and see if you can make NS subject to the formula. To make NS subject to the formula, that can be quite a bit of math, so rather just learn the formula. The next one. So notice you might be looking all over the question for the rotor speed. Don't forget, look at the nameplate and look for any other thing in RPM. Do you notice there they got full load speed? So take that as the rotor speed. Notice the question is percentage slip, so percentage is divided by 100. So 4 divided by 100 is 0.04. Substitute it and get your answer. Right, and that's the calculations there. There are also settings on setting the overload relay timer. Those questions don't really come out. There's only one in the textbook, but no paper I've seen that yet. Okay, so focus the topic on these questions here.